How many of you in the room here are mostly front-end developers versus, say, back-end? Okay, so we got a lot of good front-end developers. So you probably know this problem, right? This is the problem that you have. It's always the network and the back-end that causes the trouble, right? The product is fine. It's the distribution that's the problem. And part of that problem is HTTP. You look at this history, and you notice it ends in 1997. Until very recently, this is the protocol that was being used to deliver all those beautiful bytes that you created to the user's browser. And it took forever to get up to, to what is new. If you look at what the state of the art was when HTTP 1.1 came out, it was the Space Jam site. Think about how long that's been. Table layouts, see? Sweet, huh? Like that? I use that still. That's how old HTTP 1.1 is. Well, fortunately, we're getting an upgrade. And if you saw Crockford's talk this morning, you may have seen he was proposing some revolutionary changes. This is an evolutionary change. It's going to change. The browser already supports it. Many servers already support it. And you can change your build process to make your code deliver more effectively with HTTP 2.0. But if you don't make any changes, you're still going to be okay. It's not like the web breaks here, because obviously that's one of our tenets, right? We don't want to break the web. So the way this whole ball got rolling is a few years back, the guys at Google said, we have a real problem here. We're trying to use a protocol that hasn't been changed in more than 15 years, and we need to do something about that. So they came up with something called Speedy, and it was fast. It was much faster. And a lot of the other browsers and servers started supporting Speedy. And if you look at the current support for Speedy, it's pretty darn good. You can see all the way across the board except for Edge, and I'll explain Edge in a second, and then that's like Opera over there. Speedy is supported in all these browsers. And Speedy is a pretty good protocol. The problem was it wasn't a standard. So what happened was that everybody else saw that what Google had done was a good thing, and they formed a group. I don't know who was playing drums or who was on guitar, but they formed a group, and they sat down and they created a new RFC for HTTP 2.0. They completed it this year, and it's been approved, and it's already in a lot of browsers. So you'll see lots of green there, and you'll notice Edge now supports HTTP 2.0. The interesting thing about that is one of the reasons why Speedy became HTTP 2.0 was, and I think from now I'm just going to say 1.0 and 2.0 because I don't like saying HTTP. But the reason why Speedy was dropped or Speedy became 2.0 is because there were some things in Speedy that were actually potential performance or security issues. So if you look at what happened there, Edge decided not to implement Speedy at all because they didn't want to increase their attack surface. And also on Windows, the HTTP stack, I said it again, is actually part of the operating system and not part of the browser. So that stack is, you'll also notice that kind of off-colored green in IE11. It's only supported on Windows 10 and I think Windows 8. But IE11, even though it's supported, I think, on Windows 7 as well, you don't get support for 2.0 there because it's not part of the OS stack. So here's another example of how far we've come with support. This website here, which you can go and look at, tells about a bunch of advanced features. In this last column here is HTTP. Oh, I've said it again. I just can't stop myself from trying to do a tongue twister. But you'll notice that it's actually pretty well supported. There's quite a few browsers, including Nginx and Apache, that already support 2. So we're getting there today. This isn't something that we have to implement and deploy 5 years from now. This is something that is already on all of these servers and switches and proxies. They can pass through 2.0 protocol and handle it. Look at CDNs. Max CDN, for example, which is the provider that we use at the jQuery Foundation for code.jquery.com, already supports Speedy and will soon support 2.0, they tell me. And you look at Cloudflare. Most browsers, since they currently support Speedy, you're going to get a lot of the benefits that I mentioned in this talk as well, even if they just support Speedy. So you can see that there's a lot of support for 2.0 already out there. And there's some services, too, including WordPress. So as a front-end person, you might say, oh, well, I don't build my own infrastructure. I just use whatever they have. Well, if you're even writing a blog and you're using WordPress.com or Blogger.com, you already have 2.0 support. And if you're using Medium or Tumblr, everybody's got to have a Tumblr, then you can use Speedy and, again, get a lot of these benefits. So why did we come up with a new protocol, or why did they come up with a new protocol? Well, it turns out that 1.0 connections are pretty dumb. There's a lot of stuff that we as developers or as server maintainers do to try to make it so that we can squeeze more bytes in. The main problem is that latency, the round-trip time between us and the server, is a killer. That it's not unusual, especially in mobile connections, for it to take more than half a second for a ping, for something to get to the server and back. And that's just like, it really messes up your ability to get data to and from the server quickly. So what do we do to solve that problem as developers? We minify, we compress, we shard, we combine. You end up creating app.js and it's 500K and we jam it down the wire because that way we only have one round trip time. Now, there's a whole bunch of things that are bad about that. We end up creating these pretty complex processes to make our resources go down to the client really quickly. But in the process, we have some trade-offs. And those trade-offs, oh, by the way, I just wanted a little interlude here. I always put a cat picture in any of my presentations. So cats can run up to 30 miles an hour. I didn't believe that, but I looked it up on HTTP 2.0 is a binary protocol. Yeah, you didn't expect that. Nobody expects the cat. 2.0 is a binary protocol. That means you can't use Telnet for a session to see if the server's okay. And probably none of you have ever. How many of you have used Telnet? Oh, darn, there's always some people like you out there. Well, you're not going to do it anymore. You're going to use the tools we give you, and you're going to be happy about it. Plenty of tools that are already there can decode these sessions, including most of the browser dev tools, and I'm going to show you how those work in a minute. You don't really need to use Telnet. But there were trade-offs. Obviously, going to a binary protocol is a pretty major step because we were all kind of like that idea of being able to just kind of type things in and hit return and send headers. So what did we gain? Well, there's a whole bunch of things we gained. In 1.0, we had this problem called head-of-line blocking. And this is a great example of the kind of problems you run into. You've got a big image, and behind it, you have these things queued up that you want to use on the same connection. But in between, there are these round-trip time delays between you and the server. You get this big old image, and it finally makes it down, and then you say, okay, great, give me the next thing. And to solve that problem, what browsers have done historically is they create lots of connections to the server. Now, there's problems with that because each connection that you make to the server has to warm up. There's that round-trip time. There's the time it takes for the browser and the server to both agree on what the maximum amount of bytes is right to send between the two. So there's a window size. How many requests can be in flight between you and the server? All of that takes time to warm up. So once you get a nice, warm, cozy connection, you want to use it to the best of its ability. But you'll find that quite often that doesn't happen. So in 2.0, connections use something called streaming. The great thing about streaming is essentially the browser sends a list of things it wants and the priority that it has for what it wants to get. And so you'll see here that, yeah, we start out sending big image, maybe because it was the first thing mentioned in the file. But then I send this request saying, I really need these other files, and they're more important to me. The server can stop sending this big file and actually switch to sending these smaller files if they're more higher priority, and then resume sending the big file that it was in the middle of. And that's a streaming protocol. That's something that gives you, one way to look at it is, here we have these round-trip time delays. Now, by being able to get rid of the round-trip time delays and prioritize, we get the most number of files in the least amount of time, and we have like a whole bunch of time left at the end here that we can start using for other things. So we need fewer connections to get the same amount of work done. So we don't need to open up 6 connections to the server. We can essentially get one really well-managed, well-maintained connection. Here's another problem you have with 1.0. Headers are bloated, and it's all our fault. You know that if you work with the marketing guys in the companies that you either consult with or work for, they're always like, we'll just set a cookie. We can track the user. And so you end up with hundreds of bytes of cookies in every request because it's so important to request everything you track. Supposedly, this Google Analytics data just collects up, and then the guy looks at it, once every 3 months or something. The same with the user agent. Now, we all know the user agent is a big joke, right? It doesn't really tell us anything about the device that we're trying to talk to. But nonetheless, we send 124 bytes or more every request back to the server to say, here's what I'm lying about today that I am, right? I'm not even sure exactly what this is. This is probably Microsoft Edge for all I know, right? You can tell it's Edge because it doesn't say it's Edge. So we solved this problem with 2.0 with header compression. So what happens is there's first a static table here, and these are like most commonly made requests, like method of get. That gets translated to 1 byte. So instead of sending an METHOD : GET, carriage return line feed, we just send a single byte that says method get. For the more varying stuff, there's a dynamic table that we can send. This populates our table, and we send a byte that says user-agent : and that's one of our numbers, and then a encoded version of the user agent. We only have to send that once every connection. Once it's down on the client, we can just send a number again. We don't have to send the same bytes over and over again because we're dealing with the same connection, remember. Once we send it once, we never have to send it back and forth again. So if we go back and we look, these are some rules that as web developers that we always want to try to do to make best use of a connection. And I want to discuss and review some of the things that 2.0 does to help us keep these covenants with our servers. We want to minimize DNS lookups. We want to reuse HTTP, I had to say it at least one more time, connections. Use a content delivery network. Eliminate unnecessary request bytes. Compress assets during the transfer. And cache resources on the client. And we've already seen some ways that 2.0 helps us do this. But here's reality. This is HuffingtonPost.com. This is a web page test run looking at what happens when a server in Toronto, actually a simulated client in Toronto, goes to HuffingtonPost.com. And you can see it does the normal, oh, you're in Canada, so I have to redirect you. And then it starts requesting a bunch of stuff. But this is really not as bad as it is. It's really this bad. No, it's actually worse than that. It's this bad. 240 requests, 3.8 megabytes of data sent for the homepage of HuffingtonPost.ca. So that's reality with a 2.0 connection, with a 1.0 connection. So what is it that 2.0 is going to do to make it so that even if somebody does something that bad, it will be faster? One thing is to rethink domain sharding. The Huffington Post site actually uses domain sharding. It uses two domains, one called S, which I think is for scripts, one called I. What do you think the I is for? Images. Correct. Each one of these connections requires that setup and warm-up for TCP. And the connections compete for resources when they're going out across like a phone connection. You have to do separate DNS lookups, and then you're potentially causing TCP congestion, and that can cause retries and data loss. So even on 1.0, the performance may not be good. And I'll give you an example of that. Here's our S requests, and you notice we do some connection setup, but most of the data is requested here. And then here's our I requests, and most of these requests were made when they could have been made from the same server because we really weren't doing anything useful. And to prove that we weren't doing anything useful, you can go down and say, well, we didn't even really keep, I call it the wire because I'm an old guy. You know, we didn't keep the connection busy here. You can see there was a whole bunch of data sent early and a bunch of data sent late. Nothing really going on here. And you can see that's the case. You can actually kind of see the hole in the middle, just like a donut. There was no reason to shard these domains because we could have just used the same set of connections and we could have saved the browser a lot of work, and we probably would have gotten the data faster. With 2.0, we can actually use the same connection. And it's smart enough to say, hey, look, I see what you were trying to do. You were trying to shard, but guess what? These resolve to the same IP address. You're going to send different host headers, depending on whether you're going to S or I, but they all go to the same IP address. So I'm going to outsmart you. I'm going to actually unshard your sharding, and I'm going to just send these to the same IP address. Now, here's what's really amazing. If you have a secure connection, as long as you have a certificate that is like a wildcard certificate or that applies to multiple domains, as long as they resolve to the same IP address, you can use the same connection for a secure connection to either of those two servers, which I think is pretty awesome. So it will unshard this sharding as well. So what about cookieless domains? I don't know, how many of you are familiar with or have used cookieless domains? One of the other reasons why you might use HuffPost.com is because you set a cookie for different domains, not including I, because you don't want those 300 bytes of cookies that the marketing department made you put in there. You don't want those wasting the connection. Well, now it doesn't matter because remember, we get it down to basically 1 byte. Once we've done that initial connection, as long as the cookies aren't changing request to request, it doesn't really matter. So HPACK is going to help us out there. And you can actually use that to your advantage as well when you want to share cookies across multiple subdomains without having to worry about, oh my gosh, I'm using 300 bytes every time I make a request. So you can see that the Huffington Post site used PHP to try to combine scripts, and this is the actual URL it sends, which that alone shows you that's a pretty big URL to send over the wire. But I highlighted this because this is their versioning. So if you change any of the files that were requested here, I'm sure their procedure is to update that to 144.1810356. And then you request a different lump of bytes that probably because Facebook.js changed one line, they had to resend the whole thing. So the problem with combining files, and you see this with if you're using Webpack or Browserify, often they kind of convince you or drive you to kind of push all your files into one big lump. The thing is, you usually don't need all that right now, right? Like there's the above the fold stuff that you need, and then there's all the other stuff that you need if you're building a big app or a big page for all the stuff that's not going to be seen in that initial view. Large files take longer to download. If it's script, it takes longer for the browser to parse it. All of that's bad. So, and the big problem is if you do download that 500K file and you think, oh, well, at least now it's in the cache, you make one change to 1 byte, your 500K file is now invalidated, and you got to download the whole thing. Okay, with 2.0, it doesn't really matter if you have smaller files. Remember that little picture we saw where the round-trip times don't matter anymore. So we can actually use a different strategy where we have multiple files. Now, you probably have some 1.0 clients out there still, though, so you might want to use something like a core than more strategy. You know, you want the files that you need to handle that initial view, and then either another lump or several lumps of files that can come in after the initial view has been rendered. And tools like Webpack allow you to do that. I forgot, they call them chunks, or you can essentially break them up into smaller pieces rather than one huge app.js, have like a core.js and a more.js. And also avoid inlining. Again, this is something that now there's automated tools to do it, but by avoiding inlining, you can have caches, you can actually cache the file, and the server's going to be able to send it down pretty quickly anyway, especially because of server push. And the thing about server push that's awesome is the browser can say, send me products.html. And the server says, okay, but I've been watching the traffic. And 99% of the time when somebody asks for products.html, they ask for above the fold.css. So I'm just going to send that to you. It's only 1K anyway, and it's not going to use up much space. So even if you have it in your cache, here it comes. Think about it. The server is in a position to actually view what's going on from all the clients that make requests. It could actually do that as a predictive algorithm. It's not something built into HTTP 2, but it could be done through enhancements to the protocol on the server. Pretty awesome. Really awesome. Here's an example of what server push can do for you. With all the tricks that I've shown you, you can see up here is kind of the normal waterfall that you're probably used to seeing if you're looking at DevTools or web page test. Big, delays as you make that round trip to get the bytes, and the bytes finally show up. Here, there's a big delay for the first one, but in the meantime, we've been pushing requests to the server. And so the bytes just get there. They show up. And all you're seeing, that little piece of green, is really just the time it took to get those extra bytes at the end of the same connection. So there's a huge performance increase that comes from 2.0. And it essentially, if the browser is doing its job, it happens without you having to do anything. You didn't have to combine in these files. All the file requests are made independently. You're just getting that benefit for free. Now you may wonder, well, okay, the browser's doing its job. Exactly what job is it doing? Well, each stream in a connection has a weight. They called it a weight. I would have called it a priority. And it has a dependency, and this is where it really gets mind-blowing. So you can say, I want this resource, and you can say, later you can say, I need this resource, and it depends on one that I've already told you about. And you tell it by stream number. So I can say, okay, stream 2 is products.html, and you can say, well, I need some other file, and it depends on stream 2. And so the server can use this to help it determine what it should be sending you at the moment. And again, it can at any point suspend sending something if it gets a request for something that's higher priority. So that way you're always getting the most important stuff to you as soon as you can, rather than being blocked on something you didn't care about. So the server should deliver these bytes. One of the things that we don't know about 2.0 implementation is how good they are at paying attention to the weights and dependencies they're given. So I'm looking forward to having some people do some experimentation here to see how good they are. This is a really cool napkin. I don't think it's really a napkin, but it's probably a piece of paper drawing of how Firefox does it. And I'm going to jump down here just for a second and really annoy the video guy. So you can see that there's a session here. This is a session basically making a request. There's something called leaders and followers. And so leaders are things like JS and CSS. Followers are things like images. So when you make a request to an HTML page, usually you want the JavaScript and CSS to show up first. But then after that, you want all your images to show up. You can see here also that things that are made later, like XHR requests, have a lower priority. And there's also things that are really low priority, like like low beacons, for example, fall into that category. But it gives you an idea. This is the initial cut that Firefox had on trying to prioritize a 2.0 connection to get what you want at the right time. So here you're probably wondering, how do I know whether I'm getting this wonderful goodness and whether my page is getting faster without me having to do that much? Well, in Chrome, by default, I don't think the protocol column is there, but you just right-click on the header and you select protocol, and you'll be able to see the protocol in DevTools. In Firefox, it's in the details for each one of the items that comes down. In Edge, IE, it's here as well. If it's being served out of cache, it'll just show its HTTPS rather than actually show the protocol that was used to fetch it. I guess they don't know at that point what protocol was used. They just know it's coming out of cache. There's also a plugin that you can get for Chrome, and I think there's one for Firefox as well, that gives you a little icon showing whether 2.0 was being used. Remember, however, a page can be a mix of different protocols in use. So this just tells you, I think, whether the HTML file was fetched that way, not whether every resource on the page is 2.0. So it's really to know exactly what's being fetched, you need to go and look at the DevTools. Now, the great thing is 1.0 and 2.0 can coexist, ¿Por qué no los dos? Or should I say, pourquoi pas les deux? So, you like that? I had to practice. So, the great thing is, as I showed you, it doesn't really matter. If you look at those traces, you'll see that there were things being fetched on the same page. 2.0 was the main file. There were things being fetched by Speedy 1.1. It doesn't matter. It all works interoperably. You just want to make sure that as 2.0 becomes online and becomes so popular, that you're getting the best performance possible by taking advantage of it and getting rid of things like sharding that aren't really doing their job anymore. So, here's a list of things that you might want to take a look at. First of all, when you start dealing with servers and stuff, see if they're using 2.0. And if they are, thumbs up. If they're not, say, how come you haven't turned this on? You could see that most browsers already do it. Your browser support is there. It's really a question of whether your servers and other providers are doing the work that they need to do. And then make a few changes here in your workflow to make 2.0 work best. Reduce or eliminate sharding. Don't inline stuff. Don't create those giant app.js files. Create 2 or 3 chunks of files and get the stuff down there that needs to be there as soon as possible. And also look in your DevTools. Make sure that the DevTools are doing what they said they were, make sure that when they said they turned on 2.0, they really turned it on. And keep your eye out, because I think there'll be a lot more studies where people will say, the Apache implementation of 2.0 is really super good, but the Nginx isn't, or vice versa. So that is pretty much it for me. I think we have some time for questions. I always run short, no matter what, I told you. So please, questions here.
Just to elaborate a little more on the dependency part. So say you have some JavaScript code and it has its individual dependencies. Does the protocol actually take that into account?
The protocol, when you send a request to the server, you say, this resource that I'm requesting, the question was, how does the dependencies work? The protocol, actually, you give it a stream number of a stream that you've previously requested. That the server already knows that stream number, and then we'll say, okay, you're requesting above the fold.css, and you're saying it depends on product.html. So if I haven't sent you product.html, I'm going to send that first. There's no reason for me to send you the CSS until you get the HTML. Yeah, the question is how much of the work is being done client versus server, and how does that impact CPU and resource usage on the server? Yeah, there's definitely more work and a more complex amount of decision to be done here because now it's not just send one resource, wait for a request. I think that the trade-off that will be beneficial for servers, though, is that rather than browsers making a shotgun of 6 requests for every resource, and sometimes more because when you do domain sharding, it's really 12 or 18 requests, right, that are all coming from one little browser out there on the internet. So, that usually each connection takes up more for the server. So now we don't have that problem. It's just one connection well managed. So I think the trade-off, just kind of spitballing what the value is here, I think we actually are probably doing the server a favor by making it manage one connection rather than 6 or 12. But I don't know the numbers. Yeah.
How's the priority weighting set or calculated? And would it mean that ad servers could force their ads to be loaded before anything else?
The priority weighting is set by the browser that's making the requests. There isn't at the moment any JavaScript API surfaced for you to look or change the priority of requests. So each browser today says, well, if you make an XHR request, I'm going to set the priority, and it could just be based on the fact that it's an XHR request. It could be based on the fact that it is a JavaScript file you're asking for, something like that. But there's no way for you to control that. So yeah, an ad server, if you make a request of an ad server, then that's going to be a different connection than the connection you're making to the main server most of the time. And so it's going to need a separate connection that's going to have its own set of congestion and such. So it won't compete or wouldn't be able to override getting the images down from the main server. But I'm sure that all the people in the ad community are asking those questions too, right? Yeah.
How will load balancer deal with the fact that the header at some point is missing? So how do they track which stream goes where?
Yeah, how will load balancer deal with HTTP 2.0? And that's one of the reasons why things like load balancers. One of the charts there had big IP, the big IP switch from F5 there. Anything that's a load balancer or anything that handles traffic and inspects packets, understanding the protocol, needs to know 2.0. So in the case of 2.0, each stream coming along will have a set of headers, and the headers will say things like host, whatever. And so the switch, if it's sending things to different hosts, would need to direct different parts of that stream. It would actually have to fork the streams. Fork the streams. You never fork the streams. To be able to make that connection correctly to two different servers. There's a whole bunch of stuff in the RFC. I'm probably super oversimplifying this. So like if you're really interested in how that works, you can go look at the RFC and you'll go, oh, wow, it's a lot more complicated than I thought. But it does make things faster. Other questions? Yeah.
You mentioned that you can coalesce, if you go into one IP, you can coalesce that into one stream. Can you have multiple 2.0 connections?
So yeah, I mentioned coalescing, basically unsharding domains. Can you have multiple connections to the same server? Yes, you can. The benefit of having multiple connections in a 2.0 scenario is really not good at all, because really what you want to do is put all your eggs in that one stream basket and get the TCP window as large as it can possibly be. So if you break it into two different connections, you're not going to push more data through, really, because you're already getting maximum throughput from the single connection because it's a lot better managed. Since you prioritize, you don't have the head-of-line blocking problem that you were trying to overcome with 1.0. So although you could have multiple connections, it probably isn't something that any of the browsers are contemplating doing at the moment, I would guess. just because it wouldn't pay off. Other questions? Yeah.
Is it possible where if you have a stream set up and the browser thinks, okay, this file's too big to load, could it actually switch priority while it's loading something, or does it always finish something beforehand?
As far as the exact specifics of how it does it, it will definitely preempt an existing stream. Now, as for when it does, like if it's on a block boundary or something, I don't know those details. But if it gets something, when the server gets a request for something that's a higher priority than something it's currently streaming out, it should ideally stop the stream and switch to the higher priority stream. So now whether all these implementations do that, like you can kind of see that if they let a few more frames go by or something, probably nobody would notice. But over time, I think we'll start judging the quality of these implementations a little more strictly. Yeah.
About 5 to 7 years ago, everybody was kind of talking about script tags at the top or script tags at the bottom and things like that. If you're preemptively sending the scripts, does that change anything around that?
Yeah, that's a really good point about like how to organize things in your HTML file. And if you think about it, the whole idea of this initial pass that browsers make through the HTML, they basically are just frantically looking for things they can download. Sometimes they find a script tag, sometimes they find an image tag, and they just make, in whatever order they find them, they make them to the server today for 1.0. Because we know that certain things are higher priority, yeah, the browser has the ability now, whether you put the scripts at the bottom or at the top, it will prioritize them in a direction that gets what it needs to render the page as quickly as possible. So it still is going to honor where it is in the page. So if the scripts are at the bottom, that won't block the page from rendering. So the position still matters as far as that's concerned. It just doesn't affect resource loading order as much as it used to. So you still probably want to follow those practices, but you don't have to worry about, for example, the script being at the bottom, meaning that all of these images get requested and kind of clog up your pipe before the script can get there. Yeah.
You talked both about prioritization on the server side based on actual statistics of usage from previous visitors, and on the browser side based on what it needs to render the page. Is there a way that authors can utilize the priority to their benefit that bypasses those automatic processes?
Yeah, so the question is about prioritization both on the server and the client side, and are there ways as an author that you can affect that? There are link rel equal directives, link rel equal prefetch and preload that you can use today, even with 1.0, to do some of that. So they'll even be more effective in 2.0 because if those are considered to be higher priority resources, you can get those started down the pipe even earlier. So like link rel equal prefetch, I forgot the entire syntax, but if you look up link rel equals prefetch and preload, those will actually request things, tell the browser, hey, I'm going to need this before you've actually requested it. So in particular, things like templates or images that you know are in templates but haven't been rendered yet, those kind of things could be using those tags, could be requested. But again, at the moment, there's no JavaScript API. Like, I just kind of foresee a few years from now, we're all going to be like, yeah, that's cool, but it sure would be nice if I had some way in JavaScript to make requests for things without doing kind of hacky things like injecting tags into pages, But at the moment, there's no API for that. So, yeah.
Do you know any scenario in which version 2 is slower than version 1?
Do I know any scenario where
Version 2 is slower.
where version 2 is slower than 1.0? No, I really don't know of any because it was specifically, designed to be faster than 1.0. So I don't think there's any situation. The main concern you might have is if you have a lot of clients still using 1.0, that some of the optimizations here could potentially make your 1.0 clients slower. But you can see how quickly, especially on leading edge browsers, they all support 2.0 now. So I don't. The gating factor that you'll be looking at is, does my server, do the servers where I'm putting my resources support 2.0? And if they support 2.0, then you pretty much can go with it, unless you have a bunch of Opera users or something, that old Opera users. So I think, how are we doing on time? Do we have time for maybe one more question? Yeah.
How would it affect SEO rankings for servers like Google rankings?
Yeah, how would it affect SEO rankings? Obviously, Google has been using load times as a tool to determine whether, what your ranking is going to be. If Googlebot is now using 2.0 protocol, then you would think it would be a positive thing for SEO ranking, right? It should make it so that your pages load faster and you get some more juice. So that's a real good question. I don't know the answer specifically, but I sure would hope that Googlebot has been upgraded to 2.0 and you'd get some benefit from it. Yeah.
Have you come across any really cool back-end API stuff?
Have I come across any cool back-end to back-end API stuff? No, I haven't been looking for any, but usually I think if backends were talking to each other, they don't tend to pipeline a lot of resources, so it probably doesn't benefit as much as it would in the browser scenario where you have an HTML file and then a bunch of dependent stuff that has different priority to it. So the browser is kind of the worst case scenario as far as, now if you had something like Googlebot that was trying to fetch that way, it would help that, but I don't know if that's kind of a typical scenario though. Any other questions? I think we are out of time. So thank you very much. And please, if you have any questions, come on up.